Mr. Ryan. How are you today?
Quite good.
Okay, so today we talk about the three different algorithms to solve the problem, which is called max subarray sum.
How do you know?
Max subarray sum.
Yeah.
Okay, so given a list of numbers like 1, 3, -5, 6, 0, -1. Okay, so we want to find out the sublist, the sum of the maximum
Sublist.
yeah, the sublist sum,
Sublist.
which is the sublist which has the largest sum. So what's sublist? What's sublist? Can you tell me what's sublist? And how is that different with subsequence?
Subsequence is the thingy when you
Sublist
pick.
is equal subarray.
Pick
Okay.
thingies.
Subsequence. Remember we talked about the subsequence palindrome, yeah, the longest palindrome.
Something.
Yeah. So what's the sublist? Continuous, consecutive. Yeah.
And subsequence can be any.
Yeah. For example, the sublist is 1, 3, 1, 3, 5, -5, 3, -5, 3, -5, 6. So basically, you pick two ranges. You
The
pick two
biggest
boundaries
is
and
6 and 0.
yeah.
Actually.
Well done, yeah, consecutive. So it has to be consecutive elements, but subsequence is not, right? You can pick 1, -5, 0, right? You can pick 3, -1, no? So you
can pick
jump.
1, 3, 6.
Okay, so the task is to find the sublist which has the largest sum, okay? So, if the list has all the positive number, what's the sublist that has the largest sum?
All of them.
All of it, of course, yeah. We can keep adding, right? Yeah. And how about if the sublist if the list has only the negative numbers?
The biggest one. Biggest.
Well done, yeah. Because for example, like -1, -2, -3, so you pick the largest one, which is -1, right?
Yeah.
And it has the largest sublist. Because if you keep adding, then it will become smaller and smaller, right?
Yeah.
But if you pick -2, you can pick -1, which is better, right? All right. Okay, so good. So any idea how we can solve this problem? Like
If brute forcing.
brute forcing, yeah, well done.
The
That's a
most
very
stupid
good.
way.
The most stupid way, but sometimes the most effective way, right? Because the brute forcing is the most straightforward, most intuitive way. So how can we brute force this problem? Like,
Guessing.
sorry, how? No. How can we brute force it? How many sublists? How
If
many
all of them are positive, you do all of them.
Yeah, I know, but the brute forcing, it doesn't care about if they are not positive or negative, right? But we brute force all the pairs of sublists, right? Because each sublist is determined by the left boundary and the right boundary, right? Which can be easily brute forced into for loops. Yeah, what's the time complexity? O(n) square, right?
Yeah, O(n) squared.
O(n) square for the brute forcing the sublist, yeah? So,
Or maybe O(n) cubic.
No, but O(n) square is the
Thingy.
O(n) square for brute forcing the sublist. Look, if we determine the left boundary, yeah,
There'll be
the left boundary will be from 0 to n -1, right?
Then that'll be
Actually, -2, -1, yeah, -1. And then the right boundary will start from the left until n-1, right? Right? So for each left, I can start with the right boundary, right? So that will be O(n) square, right? Alright? Because if this is n-1 choice, actually there's n choice, and for the right one, there will be n minus. Look, if left is n choice, and then right will be n minus left choice, and because when the left is getting bigger, so this n minus left, the right is getting smaller. But eventually, it's not the number of the pairs of these sublists is n. It's roughly n squared divided by 2, yeah? But we drop the constant, so the complexity is O(n) squared, to find the sublist. Then for each sublist, we need to compute the sum of the sublist, which may take another n, right? So the overall time complexity is O(n) cubic, right?
Yeah.
But but we don't have to recalculate the sublist every time we determine the sublist, right? So for example, like
using dynamic programming.
we're done to remember it. Look, if 1, 2, 3, 4, the list is 1, 2, 3, 4, right? Right, Eric? The list is 1, 2, 3, 4. When we determine the sublist 1, 2, 1, 1, 2, we know the sum is 3, right? Yeah? But and then we want to extend this sublist to one more element. Now the new sublist will be 1, 2, 3. But when we calculate the sum of the 1, 2, 3, we don't need to start calculating from the beginning because we already know this sublist, the new sublist, is one element more than the previous sublist, right? And the sum of the previous sublist is 3. And then I can just add another 3, right? So this will save us O n time, right?
Yeah.
And what's the new algorithm complexity?
Complexity. O n square?
Yeah, O n squared because I just said we optimize it and
No,
we reduce it.
I said.
Okay, reduce it from O n cubic to O n squared, right? Okay.
Still a little bit slow.
Yeah, when n is like 100, and how many iterations you
10,000.
100 times 1,000. 100 times 100, how much?
I think it's 10,000. Yeah. Yeah.
Oh yeah, 10,000. Sorry, you're right. Yes.
I told you.
And how about 1,000 times 1,000?
What?
1,000 times 1,000.
1,000 times 1,000. 1,000, 1 million.
1 million, not billion.
1 million.
If you times another 1,000, that would be 1 billion. Okay? Yeah, does it make sense? So it's a lot, right? O cubic is a billion. It's quite slow for computer to iterate that much, right? It will be super slow, right? Super slow. Okay, so let's brute forcing it first, okay? Define, let's just call it f nums, okay? What's missing?
No.
Okay, so now
Don't
now,
need to shout.
yeah, you don't need to shout, calm down. We're done, okay? Okay, now the answer. Let's do the
Very thin.
yeah. Initially the answer will be a very small number, so we can set it to negative infinity, right?
Yeah.
And you used to know, right? I already teach you. You can do this float to convert a string infinite to a number, and I put a negative, right? And then in fact you can do this. You can do the same as this. You can do it with math. So I and f. This is a constant. Okay, it's the same thing. Okay, it's more straightforward, right? Because I want the infinity constant from the math, which belongs to math package. Yeah, domain, and then because negative.
Math.
And then current sum. Let's iterate. Okay, let's length n equals length nums, right? Length nums. Okay, length num. Then look, for let's say the I will be left boundary. I in range n, right? And then now I have determined the left boundary. I have set the s equals 0, which is the sum of the current sublist, right? And then now I need to extend the sublist to the right, yeah, in range. Start from I and then to n, right? All right. And then look, s plus equals nums. Nums what? Which element?
Nums J.
J. And then
Yay.
what happened? If I got a sum, then I need to compare with the answer, yeah? So if s bigger than answer, what should I do?
Then answer equals the S.
I'll return what?
And then return answer. Of course.
Can we make this into a max function?
A max.
Yeah.
The max of answer and S.
Yeah, we're done. Look, because this is basically we want to update the answer to the maximum of both, right? So I just have to do this. Answer equals max function. Max of what? Max of answer and S, okay? It's the same. Or S and answer. So by maximum Actually, you can pass many numbers in the max function, and you will return the maximum among all of it. Yeah. Yeah. Okay. Okay. So this time complexity. Remind me, what's the time complexity of this?
n square.
What's the space complexity?
O.
Are we using additional space? Yeah, one constant. Okay, that's good. Okay, so now can we do better? We can do it using ON loop. Okay, so we have two approaches. One is called dynamic programming. The other one is called graded algorithm. They are both quite similar in this case. They both have this ON time and O1 space. So for this, for example, let's say we have a current sublist, right? So now we want to consider the next element, right? So we want to consider the next element. We have two choices. We can either include this new element in the current sublist, or we start a new sublist with this element, right? Yeah, we only have these two choices, right? Do you have another choice? No, right?
No.
So in this case, we can do this, yeah? So for example, like 1, 2, minus 3, 4. Okay, let's just try this. Let's try with the sublist. Let's say there's an answer here. And then let's the sublist sum, okay? Sublist sum. Sublist sum.
I think it's 4.
Okay, look. Let's say start with 1, okay? 1. Both are 1, yeah? The global answer is 1, yeah? Next number, 2. I can add it, which is 3.
Makes
Or I can pick.
record.
Or I can pick 2, which is better.
What?
I can pick 2, or I can pick 1 and 2, which is better.
1 and 2.
1 and 2, so it's 3. Current
Makes a
set.
new
And then
record.
yeah, makes a new record here, right? And then now minus 3,
0.
0, or I can pick minus 3 alone, or I can use the previous plus minus 3, so it's 0, right?
Yeah.
Which is better? 0 is better. I put a 0 here, and then still this is 3 because it's not bigger than 3. Okay, and then
4.
0 plus 4,
4.
or I can pick a 4. It's the same, right?
It makes the same answer.
It's the same because you can add it together, or you can pick one, so it's the same answer. It's either way. Okay, so we got it, right? Right? That's the answer. So look, one pass, ON time, right? Because every time we make a decision, we have two choices. We either include the next number in the new sublist, or we start a new sublist with it, right?
Yeah.
Okay, let's try this problem. It's quite easy, yeah? Look,
Easy.
let's say answer equals the sublist equals the first number. Okay, let's try the first number. So look, you can write this A equals B equals C, which means A equals C and B equals C. Okay, so in this case you can write it. It's the same thing as answer S equals num 0 and num 0. Okay, in Python you can write it two ways, right? Or you can separate two lines, but this one is shorter, right? Yeah, does it make sense? This is the same, right? Yeah.
Yeah.
Okay, now for the beginning, I choose the first number, and then I need to start with the second number, right? For I in nums, I can do this. Start with the second number, right? What's column? Okay. Now look, I can pick the next number, so which is S equals what? Max. Pick the next number, which is what? I can only pick the next number, which is what?
The next number is the S. The I and the S.
I, okay, and or if I include the next number in the
I and S.
I plus S,
And
okay.
which is better than that?
Okay, then I have this current sum, and then what should I do here?
We shall.
What should we do? What should we do? Now we have the current answer. We want to check if it's bigger than the global answer, right?
Yeah.
So we can say if S is bigger than answer, then answer equals X. Or we can use the max function, which is what? Answer equals what?
Answer equals max of S.
Answer and S, yeah?
Yeah.
What's missing?
We don't know.
What's the time complexity?
O-N.
What's the space complexity?
O-1.
Okay, well done. So look, this is the dynamic programming, okay? Yeah? Because this one is we are making the dynamic programming choice. We pick this the next element
Or we can pick.
Or we start with the new list, right?
Yeah.
Yeah, you only have these two choices, right? You don't have any other choice, okay? Okay, so now, let's say another approach called greedy.
Greedy.
Greedy. Yeah, greedy. So it's quite similar to dynamic programming, except that we have the current sum, and then we only added the next number if the current sum is greater or equal than 0. If it's negative, we start the next element as the sum. Okay, so for example, let's say this 1 minus 2, 3 minus 4, 5. Okay, let's do this. Okay, so now we have the answer here. We have the current sum. Okay, current sum. Let's just do S. S equals 1. Yeah, S equals 1. Yeah, the current sum is 1, and the answer is 1, right? Minus S minus 1 plus minus 2 is minus 1, right?
Which is the one.
Okay, I put a minus 1 here, I think.
You think?
Yeah, I put a minus 1 here, and it's still 1. And now S is smaller than 0. So I don't add the next number. I start with the next number. Yeah, because now it's negative. I don't want to keep this negative sum. So I will start with next number, which is 3. Right? And then this is bigger. Okay, 3 minus 4. Yeah? Because 3 is positive, right? The sum is positive. I can add it, and which is minus 1. 3. Okay. And again, now my running sum. This is called running sum, yeah? The current sum, yeah? Minus 1. So if the sum is negative, it means that I don't want to keep these. I don't want to keep these negative sum array, and I will use the next one, which is 5.
So
Got it? So the sum.
all of them.
Yes. Is it all of them?
You can't use all of them, can you?
Can we? No.
I didn't.
Minus 1. No. No. We can't, because this is not equal to 0, right?
Yeah.
Yeah. This is also work. So this is based on the fact that we don't want to keep the negative the sum with the negative sum, right? When it's negative sum, we just jump to the next one, right?
Yeah.
We start with a new one. Okay, so it's quite similar, but it's slightly different than the dynamic one. Yes, it always works. Good question. It always works. Yeah. Because if the sum is negative, I prefer to start with a new one, right?
Yeah.
Yeah. Does it make sense? It's a bit harder to understand, but with the dynamic programming, it's easy to understand, right?
Yeah.
Okay. Don't worry if you can't get it out. It's a little bit tricky, right? Little bit tricky. Think about it when you are at school or when you don't have anything to do. You just think why it works, okay? Yeah, think about it, and if you don't understand tomorrow, and you'll tell me, and I will explain again, okay?
Yeah.
Okay. Look, let's write this. Sum equals what? 0. Answer equals math dot infinity.
Which is?
Okay, then now let's do this. For I in for I in num.
Okay.
Look, if this is slightly different, look, Eric.
Yeah.
If S bigger or equals 0, then I will edit the next number, right? Otherwise, I prefer to start with the next number. Alright, look. If the sum is bigger, if current sum is bigger than 0, it's non-negative, I prefer to start with the next number. Otherwise, I will start with next number, right?
Yeah.
And then here, answer equals max answer and what? Max answer what?
S.
S. And then what are we missing there?
Column.
No. Return.
Answer.
What's the time complexity?
O-N.
What's the space complexity?
O-N.
Oh, 1.
One.
Oh, come on, yeah? Okay, so. Okay, I'm gonna erase this. Just this bit, tiny bit.
What else could be changed?
So, if the sum is bigger than 0, we add the next number. Otherwise, we start with the next number, right?
Yeah.
So, which is what? S equals what?
If n equals I.
Yeah, well done.
I'm just looking. Gotcha.
Okay, that's it. That's it for today. Good job today. Good job. Say bye bye.
Bye bye.